A quadratic formula is a formula we can use to solve for any quadratic function that we come across. So anything in the format of ax squared plus bx plus c, we can use the quadratic formula by using our a, b, and c values to substitute into the formula to get the solutions for the equation. Now, part of the quadratic formula is what we call the discriminant, and this is that b squared minus 4ac, the part in the radical. And not so much the focus as we solve them right now, but what helps later on as we start to look at different solutions, that whatever I get inside the discriminant, if it's a positive value, I'm going to have two real solutions. If what I get here is a 0, I'm going to have one real solution. And if the radical turns out to be a negative value, that's going to give us imaginary solutions. The imaginary solutions come more into play when we look at complex numbers, which will be a different video, but it's something to be aware of as we go through them. So our goal today is just to use this formula to go and solve. So we start with x squared minus 4x minus 21. In this case, a is 1, b is negative 4, and c is negative 21. So we're going to substitute into our equation. So it's negative b, so we're going to negative 4, plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is negative 21. All of that is over 2 times 1. So we go through and simplify. We have to use order of operations correctly, but really I look at this as kind of 4 parts that we need to get together, get simplified before we go further. First, I have a negative 4. Let's make that a positive 4. On the bottom I have 2 times 1. We'll make that a 2. Inside the radical, I always have something squared and then minus a value. So I'm going to clean up these two values. So negative 4 squared is 16. And then negative 4 times 1 times negative 21. Two negatives there means it's a positive. And by multiplying them together, I get 84. So I've taken this whole thing and really condensed it down to 2 parts. The lead term, the bottom term, and then the squared term, plus or minus whatever's left here of the product. I can simplify that now. I'm going to simplify inside the radical. So we get 4 plus or minus the square root of 100 over 2. 100 is a perfect square, so 4 plus or minus 10 over 2. From here I'm going to split it into 2 solutions, 4 plus 10 over 2 and 4 minus 10 over 2. 4 plus 10 gives me 14 over 2 is 7. 4 minus 10 gives me negative 6. Over 2 is negative 3. So my 2 solutions come out to be 7 or negative 3. I didn't have to factor, I didn't have to complete the square. Using this formula gives me my 2 solutions. Let's look at some more. So 4x squared plus 7x minus 15. We start with x equals negative b, so that's negative 7, plus or minus 7 squared minus 4 times a, which is 4, and c, which is negative 15. All of that is over 2 times 4. I'm going to clean it up. Out front's a negative 7. That's good. On the bottom I have an 8. Inside the radical, 7 squared is 49. 4, 4, and 15. Well, 4 and 15 is 60. Times 4 is 240. But I have 2 negatives there, so that's a positive 240. So it's cleaned up. Now I combine terms inside the radical, and that comes out to be 289. 289 is a perfect square. That is 17. So we have negative 7 plus or minus 17 over 8. From here, look at my 2 solutions, negative 7 plus 17 over 8, and negative 7 minus 17 over 8. The first one I get 10 over 8, which is 5/4. And then we have negative 24 over 8, which is negative 3. So our 2 solutions are 5/4 and negative 3. In our next problem, we have to make sure everything is to one side, and it's in that form ax squared plus bx plus c. So I'm going to move these 2 terms over and make it x squared plus 3x minus 10. So we're going to go x equals negative b, negative 3, plus or minus the square root of b squared minus 4ac. All of that is over 2 a. So we clean it up. Negative 3 stays out in front. 2 times 1 is 2. On the inside, 3 squared is 9. And then at the 4, 1, and negative 10, there's 2 negatives there, so it's going to be a positive 49. Or 40. Positive 40. Got ahead of myself. Now, we combine terms inside the radical. Plus or minus the square root of 49 over 2. Square root of 49 is 7. They luckily have a perfect square again. So in our two solutions, we have negative 3 plus 7 over 2 and negative 3 minus 7 over 2. Negative 3 plus 7 gives us 4 over 2 gives us a 2. Negative 10 over 2 gives us negative 5, so our answers are 2 and negative 5. Let's keep going. So next one, we're going to go x equals negative 11, so I have two negatives, plus or minus negative 11 squared minus 4 times negative 3 times positive 4, all of that over 2 times negative 3. So let's clean it up. We got two negatives out front, so that's just an 11, and then a negative 6, plus or minus the square root of. Now negative 11 squared is always going to be a positive because we're squaring it, so that's 121. And then I have two negatives on the negative 4, negative 3, and 4, so that's 48. Now this turns out to be 11 plus or minus the square root of 169 over negative 6, which is a perfect square, so we get 11 plus or minus 13 over negative 6. So we have our two solutions. We go 11 plus 13 over negative 6, which gives us 24 over negative 6, or negative 4. And then 11 minus 13 over negative 6, which gives us negative 2 over negative 6, or 1/3. So our answers are 4, negative 4, and 1/3. For our next one, 7x squared minus 2x, c equals 0 because there is no c value. So let's see what that does to our formula. So we're going to go negative 2 plus or minus negative 2 squared minus 4 times 7 times 0 over 2 times 7. So we clean it up. We have a 2 out in front, 14 on the bottom. On the inside, negative 2 squared is 4. But then 0 times anything is 0, so it's really just plus 0. So we're in fact just doing the square root of 4. So we have 2 plus or minus 2 over 14. 2 plus 2 over 14 gives us 4 over 14, or 2/7. 2 minus 2 over 14 gives us 0 over 14, or just 0. So 2/7 and 0 are our two solutions. In the next problem, if I subtract the 48 over, I have b is 0 in this case. So let's see what that does to our formula. So we start off with negative 0, or just 0, plus or minus 0 squared minus 4 times 3 times negative 48. All of that is over 2 times 3. Now we do have zeros there, but it doesn't get rid of everything. So the 0 in the front's gone, so it's just a plus or minus a radical. That's 0 squared, which is 0. So what we need is 4 times 3 times 48, and that is 576. And that is over 6. Now 576, let's see if that's a perfect square. It is. It is 24. So we get plus or minus 24 over 6, or plus or minus 4 as our two answers. And you could write it as that, or you could say 4 and negative 4. Next problem. we have a, b, and c. Those are all back. So we're going to go negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 4 over 2 times 3. Clean it up. We got negative 2 and a sixth on the bottom. We go 4 and then a plus 48. Now this one is going to give us a radical that doesn't simplify, but we need to, or isn't a perfect square, we should say. But we can simplify it because square root of 52 is 4 times 13, so this is going to become 2 root 13. So when this becomes negative 2 plus or minus 2 root 13 over 6, we can reduce this down because I can divide 2, 2, and 6 all by 2. So it becomes negative 1 plus or minus the square root of 13 over 3. Not the cleanest answer, but we can't simplify the radical, and we'll leave it as that. Last row here, we're going to go 3p squared plus 4p minus 10, because we need to move them all to one side. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 10. All of that is over 2 times 3. We clean up what we have. Negative 4 is on top, 6 is on the bottom. On the inside we have 16 from 4 squared, and then 4 times 3 times 10 comes out to be plus 120. Now, this gives us negative 4 plus or minus the square root of 136 over 6. So we need to see if we can simplify 136. So if I look at 136, it is 4 times 34, which gives me a set of 2's, and 34 is 2 times 17. So this is going to become 2 root 34. So that means negative 4 plus or minus 2 root 34 over 6 is simplified. Then, like the previous problem, we can divide the 4, the 2, and the 6 all by 2 to get an answer of negative 2 plus or minus the square root of 34 over 3. For our last problem, we're going to go k squared minus 4k plus 4 equals 0. Let's go negative, just make those k, not x's. Alright, so we're going to do our quadratic negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 4. All of that over 2 times 1. We clean it up. We got negative 4 on the top, 2 on the bottom. Inside we got 16, and then 4, 1, and 4 is to be a negative 16, which we look at it, and suddenly that's negative 4 plus or minus the square root of 0 over 2, which is negative 4 over 2, so an answer of negative 2. So in this case, one solution to the function.